Hi there, I'm Karolina, Python developer at Oxylabs, and today I want to talk to you about a very exciting topic, which is AI and web scraping, the unstoppable duo for web data collection. On today's agenda, we are going to answer the question, what is artificial intelligence and machine learning? How can AI be used in web scraping, and how is AI used in Oxylabs products? Then I'm going to show you our e-commerce scraper API demo and talk about notable features of scraper APIs. I'm going to finish off with a summary. If you have any questions during the webinar, please submit them in the chat box below, and we will try our best to answer them during the webinar. So, web pages continually evolve to improve user experience. As a result, gathering public data may become problematic because while these modifications make websites more appealing to users, it can become a bit of a headache for developers when gathering public web data. In moments like these, they turn to AI. And now let's answer the question, what is artificial intelligence and machine learning? Artificial intelligence is the broadest term which refers to a machine or computer system that performs tasks that typically require human intelligence, such as learning, perception, and decision-making. Machine learning is a subset of AI, which is training computer algorithms to identify data patterns and make predictions based on that data. Deep learning is a subset of machine learning, which uses neural networks which are modeled after the human brain to learn and make decisions. These algorithms can automatically identify features in data and use them to make accurate predictions based on the patterns in the data. So let's answer the question, how can AI be used in web scraping? In general, it can be used to solve repetitive problems that occur on a high scale. AI-based web scrapers have skyrocketed in demand to help automate repetitive daily tasks, speeding up and saving the costs of data collection from thousands of websites simultaneously. And now I would like to talk about Oxylabs classification model, which is used in multiple features of our scrapers. So Oxylabs classification model is made with these steps. First of all, we do data collection and identification. We collect lots and lots of HTMLs containing different website layouts, and then we identify the data either by XPath, by defining the depth of an item in a website layout, or by visual position of an item. Then we do data labeling, which is identifying raw data based on its content. And after data labeling, here comes model training, which is an iterative process of tweaking parameters in order to reach a certain level of familiarity. And as a result, we have a collection of website layout knowledge based on HTML tags usage, their relative positions, and other attributes to determine newly encountered elements when dealing with a new target. And as I mentioned, a threshold of familiarity is achieved, and past the threshold, a new website rarely requires hands-on input from a software developer. So, knowing this process, we can tell that labeling the data and collecting it is the most important and time-consuming step because of the importance of this data, which is used when training the model to reach the best result. And now I will tell you all about this classification model's usage in Oxylabs products. In general, changing website layout breaks the parsing script until manual adaptations to a new layout are done. This requires a lot of repetitive manual work from software developers. This is why we have developed an adaptive parser. Our adaptive parser is used to parse product pages of e-commerce sites. So when using this adaptive parser, you don't have to set up or readjust a dedicated parser for an individual web page. Adaptive parser does it for you. And the best thing is that the more sites this adaptive parser learns, the better, because it becomes more and more accurate. Now, another application of this classification model is response recognition. We all know that, for example, 400 status codes returned from the website means that the website probably blocked us. However, when checking the quality of the response from the website that we scraped, we have to look at both status code and the content of the website, because in some cases, block content is returned along with a 200 status code, which usually means success. And this is why we have developed a response recognition model, which is trained on a lot of HTMLs that contain CAPTCHA pages and other block content types. This model is developed a bit differently from adaptive parsing model because instead of having different positions of elements in the website and labeling the HTMLs by these positions, all you need to do is label the HTML content by either containing the block content or not containing it, which is basically a Boolean. And the most challenging part in developing this model is also collecting the data, because you need to collect all different types of content in different languages apart from English, because block content can be seen in different languages. And then this model or this feature using this model is combined with an auto-retry system, which checks the status code and the content of the website and triggers a retry if needed. And the third and final application is proxy management, which basically selects and rotates and evaluates the most suitable proxies that result in the highest success rate in the lowest retry rate possible. Now, I would like to talk about scraper APIs, which are the solutions that incorporate them all the features that I've mentioned before. Scraper APIs are data scraper APIs designed to collect real-time data from websites at scale. We have 4 different scraper APIs. The first of them is SERP scraper API, which scrapes search engines. Then we have e-commerce scraper API for e-commerce sites, real estate scraper API, and an all-around general purpose web scraper API for all the remaining targets. And now I would like to show you a demonstration of e-commerce scraper API, showing you how our block detector works and how this e-commerce scraper API can parse the data adaptively. So what I have here for you today is a quick script that showcases our e-commerce scraper API features, which are adaptive parser and block content detector. I am using our real-time integration method, which leaves the connection open, and after retrieving a response, we're going to save it to either a JSON if we're going to parse the content, or to an HTML if you're going to scrape it. So first of all, let's see how this adaptive parser parses the data of an e-commerce product page. Let's open this website in the browser. And there we have it. We have title, product price, product images, and some specification of the product, along with a huge description right here with some more specifications. And now let's go back to our script and let's run this demo script. All right, this parse result should have been saved to a JSON file. Let's open it up. And as you can see, our adaptive parser parsed the product IDs, brand, image, price, title, description, availability, and all the additional properties there were. Now, let's showcase a different feature, which is block content detection. I want to open this website in a browser. So you can see what content we get. As you can see, the site is under maintenance. However, when using our Scraper APIs, along with our block detector, we can get structured, scraped content from this website. So let's run the script. All right, as you can see, we were actually able to retrieve good data from the website. As you can see, the layout is somewhat similar. It has a product title, product price, image, and some product information right here. Now, let's try to parse it. Let's run the script again. All right, it should have been saved to parse result.json, and there it is. As you can see, product IDs were parsed along with brand, image, price, title, description, and all the additional properties as well in the same unified structure. So our adaptive parser can parse different layouts and retrieve the same information from various e-commerce product sites. I would like to also mention some other configurable parameters that you can add to your scraping request, which are JavaScript rendering. Whenever you would like to scrape dynamic content, which is loaded using JavaScript, you may also provide user agent type to be a desktop, tablet, or mobile, depending on your choice. You may also provide a callback URL whenever using push-pull method. You may also provide locale or make a post request with your own headers, cookies. You may also reuse session or provide successful status codes whenever target website retrieves good content along with an unusual status code. All right, that's it for the demo. Now I would like to note other features of Scraper APIs. First of them is JavaScript rendering. We are using a headless browser to not only load dynamic elements in web pages, but also generate a unique web fingerprint that allows us to remain unblocked. Also, we have dynamic browser fingerprinting, which is basically a feature which selects the right combination of headers, cookies, and browser attributes to retrieve quality data. Also, I would like to mention multiple integration methods that can be used when integrating Scraper APIs. In my presentation, I showed an approach which is synchronous, which is real-time. It opens a connection which timeouts after 150 seconds and waits for a response. It waits to receive a scraped result. Other synchronous integration method is proxy endpoint, which can be integrated as a proxy. If you already use the proxies in your web scraping infrastructure, then this integration method can be really easy for you. And also we have an asynchronous integration method, which is push-pull, where you submit a job to our Scraper API and it returns a job ID. This integration method can be combined with a callback URL which by providing callback URL, you can be sure that after finishing the job, the callback URL is going to be pinged. And this integration method can also be combined with our multiple delivery options, because you can deliver script or parsed data to your AWS S3 bucket or GCS. And now let's finish off with a summary. So AI can be used to solve repetitive problems that occur on a high scale, which is also the case in web scraping because of changing website layouts and our aim to both ensure quality of script data and extract structured data on a high scale. Oxylabs classification model learns the concept of similarity between the target websites and, as a result, is able to adapt to always changing website structure. Our Scraper APIs incorporate the classification model, which not only detects blocked content, but also returns structured data of e-commerce product pages. And now we are going to answer the most commonly asked questions. So, this first question is, how do I know when I need to use adaptive parser parameter when scraping? In general, adaptive parser parameter should be used when trying to retrieve structured data from an e-commerce site and this e-commerce site's product page. In general, you should refer to our developers' documentation to see whether we have dedicated parsers for the targets that you want to retrieve structured data. Why do websites change layouts? How do I know when it happens? Website change layouts in order to improve user experience. You will know when it happens because your parsing script is simply going to break, and it's not going to retrieve the same information that it used to, which means that the positioning of the data that you parse was changed in the layout. Its XPath and depth is not the same as it used to be. If that happens for a target that retrieves structured data from our dedicated parsers, I suggest contacting an account manager, which is dedicated for you, which will refer this problem to our developers team. Another question is, does your tool parse all e-commerce websites? Yes, our tool parses all e-commerce websites, but specifically their product pages. The more product pages it can parse, the more accurate it becomes. However, if you would like to retrieve structured data for not only parse products, for not only product pages, but also search pages and category pages, I recommend waiting for us to release our custom parser, which is going to allow you to send your custom parsing instructions, and it is going to support XPath and CSS selectors. And as a result, you can create a custom, very specific parser that will retrieve the information that you need. What are the main differences between Web Unblocker and e-commerce Scraper API? So the main difference is that Web Unblocker is dedicated. It is a machine learning powered proxy solution that is dedicated to unblock even the most complicated sites and the most sophisticated antibots. It is integrated as a proxy, while Scraper APIs have different integration methods, and also Scraper APIs can retrieve you structured data incorporating this adaptive parser that I told you about. Now, the other question is, which integration method is the best? In general, this purely depends on the volume of the data that you're going to scrape. If you're going to scrape large amounts of data, I highly recommend using push-pull method, which is an asynchronous method. When using it, you are going to post a job to our Scraper API, and get a job ID, which will then can ping your selected callback URL, and you can also put this information, the script information or parsed one, to your AWS or bucket or GCS. All right. So if you, for example, are have already used proxies in your infrastructure, you can also integrate Scraper APIs as a proxy endpoint, and also you may use a real-time integration method that is synchronous, which leaves the connection open and waits for a response. And yeah, that's it for the questions. Thank you for being here with me today. And if you have any more questions, submit them to events@oxylabs.io, or you can contact me via LinkedIn, and I will wait for your questions there. Thank you, and see you next time.